So in a bubble sort, as we saw in the last video, we need to keep track of two important things. One of them is the current index, which we are going to represent going forward by CI. And as we know, this CI moves from 0 to the first sorted index. So, which is basically CI is going to move from 0 till first sorted index. Or let's call it short for FSI. So that obviously brings to our second important thing we need to keep track of, which is of course the first sorted index. Now if you're wondering what is first sorted index, I'm going to tell you in a minute, well, in a second. So first sorted index is basically nothing but the position in the data set where the sorted part of the data set starts as the algorithm progresses. So that's, I'm going to write it down here. It's going to be the first sorted position in the data set. Those two things said, and as I just said, CI moves from 0 to the first sorted index. Let me write it down. So for a data set of n elements, CI, if FSI, which is our first sorted index, is kth position, then our CSI, sorry, not CSI, it's CI, or CI moves from 0 till k minus 2. And why is it k minus 2? Because as we know, let me write down why k minus 2. Because we know that because CI is compared with value at CI plus 1. So if k is equal to say 2, then CI would be comparing 0 with 1, and that's how far it can go. So when CI is equal to, so basically that is if CI is k minus 2, then we compare k minus 2 with k minus 1, and there is no need to compare anything with k because k is already sorted. So let me write it down. If CI is equal to k minus 2, scroll, then I'm sorry, so if FS should say if FSI equal k minus 2, then CI compares k minus 1 with k minus 2. And we don't need to go any further down, and you'll see we will continue this until CI cannot move any further, that is until FSI becomes 1. So when FSI, which is the first sorted index, becomes 1, CI, would have a value from 0 to k minus 2, which means it will be 0 to minus 1, so it can't go any further, and we exit the loop. So let us see how we move the FSI first, which is the first sorted index first. Since initially nothing of the dataset is sorted, FSI points to a position outside the dataset. So if we have a dataset of n elements, then its indexes will start from 0 to n minus 1, and FSI will point to the nth position. So watch, if we have a dataset of n elements, let's keep remember that we always think that our dataset has n elements, then it will be like this, represented as an array. It will be the 0th position, first position, second position, blah 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 blah, until it's n minus 2 and n minus 1. So our FSI at that point would be pointing to this position, which is basically outside the array, which is the nth position. So why is it pointing to the nth position? Well, initially, because nothing of the dataset is sorted, we have nowhere else for FSI to point to except outside of the dataset, which is the first position outside of the dataset is obviously the nth position because our dataset index goes from 0 to n minus 1, and the nth position is outside. Nth position is the first position outside of our dataset. So that brings us to our program, which is basically how would we express this movement of FSI from the nth position to our first position. So that's how our FSI moves from the nth position to the first position. Now, how would we express it? Okay, so let me write it down. FSI moves from nth position, which is basically a situation where all the data set is unsorted, to the position 1. Or let me write down first position, where all data set is sorted and no part of the data set is sorted. So FSR moves from the nth position where no part of the data set is sorted to the first position where all the data set is sorted. So if we were to express this as a program, how would we write this, right? Let me write it down. So we're gonna, in Java, I guess it's pretty similar in C++ as well, but I'm gonna write it down here. For int, we're gonna use an int loop. We're gonna move FSI from the nth position where n is the length of your data set, if we were to say, and FSI is greater than 0, which basically means it will go until 1, FSI minus, so, and that's how FSI moves from the nth position to the 0th position. So for example, if n is equal to 5, FSI values goes like this. It'll go for the 5th position, to the 4th position, to the 3rd position, to the 2nd position, to the 1st position. Right? With that sorted out, let's see. Now we already demonstrated in a bubble sort, it involves continuously searching for the largest element in the unsorted part and moving it to the sorted part. So what's bubble sort? Let me write it down again here. Bubble sort involves continuously finding the largest element in the unsorted part and moving it to the sorted part. Right, with that said, so initially, if we were to take our array, let's say if n is 5, example, we're going to have 0, 1, 2, 3, 4, 5, and let's say an yellow line indicates what's the sorted part and what's the unsorted part. So this is initially the unsorted part. This is sorted part, which is nothing basically. So our FSI, as always, points to where the sorted part starts. When FSI is equal to 5, this is what it's going to be. When FSI is equal to 4, we're going to write down here 0, 1, 2, 3, 4, 5. Now, sorry, this has to be, let me make a correction here. If FSI is for a data set of 6 and is equal to 6, FSI is equal to 6, and this is what is going to be when FSI is equal to 5, when FSI is equal to 5, 6, and here it's going to be 5, and our yellow line at this point is going to be right here, and this is the unsorted part, and this is the sorted part. And as we progress, FSI will move on until it's 1. As we progress, we're not going to write down every step, so this is going to be 0, 1, 2, 3, 4, 5, and gonna write this is the FSI 1, and this is the sorted part, and this is the unsorted. So that's the goal. So as we know, the boundaries of the unsorted part therefore range from, at any given point, from 0 till FSI. So that's the boundary. So writing it down, so the boundaries of the unsorted part range from 0 till FSI, and we know that we use CI, which is the current index. We use this to find the largest element in the unsorted part, and we move it from 0 to the FS. We move it to the sorted part, and And as we know, CI moves from 0 till FSI minus 2. And in this part, which is basically the unsorted part, this is where we will try to find the largest element. And if we were to express this as a program, CI, which is basically this. So let me show an example. So CI, what is CI? Finds the largest element in unsorted part by comparing CI with CI plus 1 and doing a swap. If value at CI position is larger. So that's how we do it. So CI goes from 0 to FSI minus 2, so it keeps comparing the elements and keeps sorting. If you're not clear on how CI progresses, take a look at my other video, the earlier video, and I'm not going to go over that again, but over here the goal is to write a program for BubbleSort. So I'm going to write the program of how CI progresses. So in Java, and again pretty similar for C++, for int CI is equal to 0, CI less than or equal to FSI minus 2, CI plus plus. So how does this progress? Let's show an example. So for a value of, for n is equal to 6, for FSI is equal to 5, CI goes like this. CI goes like, CI goes from 0 till 1 till 2 till 3, and it can't go any further, so it'll compare so when FSI is 5, it'll compare, CI will compare 0 is compared with 1, 1 is compared with 2, 2 is compared with 3, and 3 is compared with 4. So that's how, let me write down the comparisons. Compared, and towards end, CI would move, this is the comparisons, let me write it down. Towards the end, CI will move the largest element among 0, 1, 2, 3, 4 positions to the 4th position. So that's the goal. The goal is to move the largest element to the last position of the unsorted part and make that position part of the sorted part. So expressing this in the program, we already did this here in the Java, and now we're gonna write the swap of how CI keeps finding the largest element and keeps moving it towards the end of the unsorted part. So as we know, for a swap we need to store one of the values in a temporary variable. So we're gonna write the program for swap. Let's say, how do we do the swap? Let's put a heading swap. So the goal is if the value at, let me scroll down, if the value at CI is greater than value at CI plus 1, then the goal is to store in a temp variable the value at CI plus 1. So, and then we're gonna store in position CI plus 1 the value at CI position, then store in position CI the value from temp variable. So that's how a swap is done. Now expressing it in Java, we're going to declare the temp variable is equal to 0. And if we were to say that our data set is represented in an array, and the array variable is, let's say, ARR, then we're going to do the swap like this. If array CI is greater than CI plus 1, open brackets, our temp is going to store the value at plus 1, then we're going to do, forgot to write the plus 1 here. Plus 1 is equal to, should have just said this CI, and temp. And this is how we're going to do the swap. This is the program for the swap. Now, as we know, this code for checking CI with CI1 and performing the swap is repeated for every value of CI. So this needs to be within the CI's loops. So that brings us to our next part, where we combine. Now combining CI loop code with the swap code, we get this. Perhaps let me use a different color for our code, maybe brown. Let's see how it looks. So we're going to do we're going to declare our variable first. There's no point in repeatedly declaring it. Put it outside of the loop for int ci is equal to 0, ci is less than or equal to fsi minus 2, ci plus plus. We open our brackets. If array of ci is greater than +1, temp is equal to +1, close the brackets, and let's indicate what it is. If swap, and we're going to close the for loop. We're going to indicate for ci. So that's combining the CI loop code with the swap code, and that's what we get. We're going to combine the CI loop code plus the swap code. Let me write down, this is Java. Okay. So with that said, now we are going to, the next step is to, as we know, the value of CI moves from 0 to FSI minus 2, and the value of FSI is determined by our outer loop. We need to combine. Now let's write down that. Now combining I don't know, it came like that, but now combining FSI code plus the CI code plus the swap code, which is all the steps we need to perform the BubbleSort. We get our final program, which I'm going to write down here. So let me change our color to our interesting brown. This is what we get, and this is the final program. Well, we declare our temp variable, we set it to 0, because sometimes if some of the variables are not initialized, we're going to get an error from the compiler. So we're going to initialize it to 0, even though I know Java by default initializes it, initializes the variables. However, I did notice it sometimes it tells you that you're using an uninitialized variable kind of warning. So just to be safe, we're going to initialize our variable, and we're going to write our code where FSI is greater than 0, FSI minus minus, we open our braces, for CI is equal to 0, CI less than or equal to FSI minus 2, CI plus plus. Now let's write our swap code, which is if CI greater than temp is equal to +1, temp, and we're going to close our if swap, and we're going to close our for CI, and we're going to close our for FSI. So there you guys, that's the final BubbleSort code. Alright, that brings us to the end of this video. I hope you find this helpful. I plan to do more videos with other algorithm techniques and their applications and as such. So keep a lookout for that. Thank you.